Hello, I welcome you all. The problem reads locate the centroid Y bar over the beam's cross-sectional area. This problem is coming from the Engineering Mechanics Statics 13th edition by RC Hibbeler. Alright, so here what we have been asked is to find this, and since this is a composite body, made out of 3 different parts. So sum up the Y logocentroid of each one of these sectional bodies times this individual area, then divided by the summation of area. Okay, so do that. So what we'll do is we have 2 parts, 3 parts, but the 2 are the same. So I'll have this one. Okay, I'll have this one here. Alright, and then I'll have the 2, which is this one there. These ones, there are 2 of them that are similar. Alright, right, there we go. So let's call this 1, and then let's call this 2. Okay, since these are the same and they're symmetrical about either axes, about this axis or about this axis. Okay, all right. So what we need to do now is to locate these points. So let's say we have the local centroid for this one. I'll bring it down a bit so that we are able to see it. I'll do this like this. Okay, something like this. Right, okay, right, there we go, something like that. Okay, all right, so we have something like that. This point here. Okay, so let's call this here, let's call this one here is y. So we said this is 2 also, so y curled 2 is equal to half of 200, which is just equal to 100, and this one is y curled of 1 is equal to 200 plus half of 50. Okay, and this is equal to 225. 225. Okay, I think this is about it. Let's find the areas. So we have area 1. This is just going to be equal to area 1 is equal to 15 by 400. Okay, this just gives us a 20 by 10 to the third. Then area 2, I knew there are two of them. This is just equal to 200, okay, by 50, and this is just going to be equal to 10. This is 10 by, like so. Okay, so let's draw up. We know the number of that we need. Alright, okay, we'll draw something like so. This is the title. We have the first one, we have the second one, we have the summation. Okay, so this one is for part. Okay, and then this one is y count, then we have area, then we have summation of product of centroid by area. Alright, let's add some details to that table. So this is part number, then this one is y count. This is y count, and it is in millimeters. And then this one is area. This is millimeters squared. And then we have y count area. Okay, it's in millimeters squared. So we have 1, we have 2, and we have summation. Okay, so this one is 225. This one is 100. Okay, area for the first one is 20 times 10 to the third. The other one, there are two of them, so it's 2 by 20. Okay, 10, 2 by 10, sorry, by 10 to the power of 3. And then we multiply now this. So this just becomes, we have that by 20 like that. So this we get 4,500 times 10 to the third. This also just becomes 20 by 100. We have a 2,000 by 10 to the third. Okay. Alright. Then let's sum up the area. So area here will have just a 40, 10 to the third. Then here we have 6,500, 10 to the third. Then we have y bar. Y bar is just going to be equal to summation of y count by area divided by summation of area. This is equal to 6,500 times 10 to the third. Sorry, this one is to the power of 3, not 2. Okay. Then divided by summation of area, which is just 40 by 10 to the third. Then y bar is just going to be equal to 6,500. The other part cancels out, so this gives us the 162.5 millimeters. Does this make sense? Alright, it does. Okay, there we go. So this is the centroidal location along the y direction for this particular cross-sectional beam. So So I hope this particular video was helpful, and if it was, give me a thumbs up. Like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.